Hello, in this video we're going to look at solving a basic trigonometric equation, and by basic I want to make sure we understand that it's as stripped down as it can be. So normally when you're seeing a trigonometric equation, it's y equals a, and it's usually sine, cosine, or tangent. You can do, of course, you can work with secant, cosecant, and cotangent, but they're reciprocals and you can solve it so that you get this form. So you have coefficients a, b, c, and k, and if I purposely look at just the ones that are where a is 1, b is 1, c is 0, and k is 0, that's as easy as you can get, as basic as you can get. So you'll basically just have y equals sine x, cosine, or tangent x, and then there's a number filled in for y, and you're solving for the angle x for which that's true. Okay, that's what we're looking at. Now I'm going to solve this one, cosine x equal to 0.28. So here's the graph of the cosine function, and then here's, so that's y equals cosine x, and here y equals 0.28, right? How high is y? It's 0.28. So essentially everywhere that there's an intersection, like here, 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 and on infinitely, you're dropping down the x-axis and seeing what is that angle that makes this true, right? Now, specifically, I'm going to look at these solution sets where you're solving for the angles between 0 and 2 pi, all real, and then negative 3 pi to 3 pi. It could have been any of these intervals. These are very typical, and then sometimes you're asked to find all the solutions within a specified interval, and I just picked this so that you could see, well, what's the strategy, okay? So here's the process I use. So I always ask myself, for what angle is the trig ratio equal to the given number? And it's understood you can only look within the theoretical restrictions. Then I take the inverse function of both sides. I find the first solution using the calculator. I find the other solution basically visually drawing the unit circle. Then I write all the solutions, what I call generator. And then if I have to, I need to put integer values into the generator to find solutions in the specified intervals. So we're going to look at that. So first I'm going to, let's say, write this down. So I could write y equals cosine x is what I'm solving, but I want 0.28, and I'm going to go ahead and use theta, right? It doesn't matter what angle this is. This is always the input to a trig function is an angle. Just so it's really obvious it's an angle, I'm going to write theta, but x is an angle. I could have called it 2, anything I wanted. It's just a placeholder, and it's for an angle. All right, so what I want to say is, for what angle, and you don't even have to write angle, you can write theta, now where am I allowed to look? Since it's cosine, you're allowed to look between 0 and pi, and anywhere in here, right? So it's included, 0 and pi. Is, now understood, the trig ratio, right? The trig ratio, it's cosine, so let me go to the definition of cosine. This is extremely important. X over r is what cosine, right? Is the definition. Or I could write x over 1 if I want to use the unit circle, and then that's really just the x coordinate. A length of 0.28. That's really what I'm looking for, right? So that's step number 1. Step number 2, now that I know what I'm looking for, I want to go ahead and start solving this. If I have cosine of theta equals 0.28, I need to take the inverse cosine of both sides. And essentially this right here is f inverse of f of x, right? And then these are inverses, they undo each other, but that's only true because I'm following all the theoretical restrictions and finding the solutions in here. So the calculator does that for me. So then I say, oh, well then theta is the inverse cosine of 0.28. So now what I do, so this is part 2, take the inverse function of both sides, and now I'm going to find the first solution using my calculator. So part 3, calculator, solution. All right, so I go to my calculator, I make sure in my mode that it's in radian mode. And in another video we'll talk about why, but always best to solve in radian mode. So then I want to say second cosine, so that's inverse cosine, and put in 0.28. 28. And I get 1.28700 and so on and so forth radians. Now, it's good to go out 4 or 5 decimals if you want. You need that kind of precision. Okay, and I'm going to just write radians, but it's understood. I don't have to write it. If I don't, it's understood radians. All right, so now I've found the calculator solution. Now what I want to go is find the other solution. I'm going to find the other solution outside the theoretical restrictions. So what do I mean by that? Well, so this is 3, we just did 3a, so I'm going to look at 3b. So what I'm saying is, here's where what I just solved for. I rotate a certain amount, how much? 1.27, I don't know. So remember, all the way up to here will be 1.57. So let's say I go 1.28700 radians, right? And then I drop down perpendicular to the x-axis to create my reference right triangle. And this is the x-coordinate. Obviously, this is the y-coordinate. I want to know where is it that the x-coordinate is 0.28, right? So I found it. The calculator found this one. So this length is 0.28. Well, if I were to reflect this, where else is the x? A positive. So the question then is, where else is x equal to positive 0.28, right? That length. Well, it would be where x is positive, so it's either quadrant 1 or quadrant 4. We've already solved for quadrant 1. So quadrant 4 would be when you reflect this, right? Come down here. Same length. But what is this? What is this angle? Well, in this case, I can look at it as going the same amount of radians, 1.28700, but instead of going positive, going negative. So this is negative 1.28700, right? So that's one way to put it. So I could say theta is negative 1.28700, right? Well, that's just fine. There's nothing wrong with that. However, a lot of books don't like that. I don't know why. There's really nothing wrong with that. And I'll show you at the end. You come out with the same solutions, and I'll show you why. So what we can do is say, well, suppose instead I went 2 pi and then backed out 28700. So here's the motion that I'm talking about to get here. I could just rotate this way, which is in the negative direction, 1.28700, or coterminal angle, right? I add 2 pi to it. So I go 2 pi all the way around and then come back this way, right? So that's the same thing as taking this and adding 2 pi. So I could say, or theta equals negative 1.28700 plus 2 pi to get the coterminal angle, which is 4.99619, right? Both are fine, right? So because the book tends to deal with this, I'll go ahead and use this, but this is just fine. So that's 3b, find the other solution. Now 3c is extremely important. We're going to write the solutions in an infinite way so we capture all of them, because remember, in our graph, this goes on forever and ever and ever. What we found was probably right here. See how negative pi over 2, by the way, every one of these major lines is pi over 2. We're here at negative pi over 2, that would be negative 1.57 about. So we're here at negative 1.28700. But remember, there's a bunch more. There was also positive 1.28700. So what you're going to see is, I kind of look at it as, if I'm on the wave, I'm on the right-hand side or the left-hand side. All the right-hand sides are a distance of 2 pi apart, right? So if I look at this one here, which is 1.28700, that is also 2 pi apart from here. So from here to here, right, that's plus 2 pi. And so on and so forth. I mean, if I go here, here's on the right side, if I'm here, this would be minus 2 pi from 1.28700. I could look at it when I solve for the negative, right, for the other solution. That's this one. Negative 1.28700. Well, that one's, like on the left side, that one's going to be 2 pi apart from here. Right there. So that's plus 2 pi from that one. And then if I go over here, the left side, right, this is minus 2 pi from that. So basically what I want to do then is kind of get to all these. Oops, I wrote all over this, didn't I? So to do answer 3C, which is capture all solutions, I would start with this one. So theta is 1.28700 plus 2k pi, right? Where k is an integer. And then you also want theta equal to the second set of solutions, which was either negative 1.28700 plus 2k pi, or you could say 4 point, what did we get here? Oh, 99619 plus 2k pi. So these two are going to give me equivalent solutions. All right, so that's this part up through 3C. And then 3D is to go ahead and input integer values of k to find solutions in the specified interval. So if we go back to where I started here with the 3 questions, if I only want solutions from 0 to 2 pi, so let's go ahead and do that. Well, you can see it on the graph, right? Here's 0, here's 2 pi, let's see over here, right here. Right, I only want those solutions. And it looks like I've only got 2 of them. I've got this one and this one. So 1.28700 and this one, which is the 4.99, whatever that was. So for part A, I would say 1.28700 and 4.99619 radians, right? Then B, if I'm looking for all real, I've got to get them all. Well, that's really our answer from 3C, right? That's what I call the generators, but that's just my terminology. So I would say theta equal to 1.28700 plus 2k pi. And let's go ahead and just say 4.99619 plus 2k pi. Understood, k is an integer. Okay? So that's part B. Second one. And finally, if I want to find a specified interval, in this case from negative 3 pi to 3 pi, well, that's from here to, let's say, here, right? And what we can see is I've got 1, 2, 3, 4, 5, 6 solutions, right? 3 of them coming from one generator, 3 of them coming from another generator. Now, generally what happens is you could start your generator anywhere. Usually they start close to 0. So what we did is we started it here, 1.28700, and then one hop would be k equal 1. Going the other direction would be negative 1. And this would be k equals 0. So this is k equals 0, k equal 1, k equal negative 1. Whereas with this one, if we started, let's see. Let me see what I did for you all. If we started with this one, 4.99, right? That would be here in the greens. So right here. Then what we would have, this would be k equals 0. This would be, we don't have k equal 1. You'd have to do k equal negative 1. Wait, I'm here, sorry. K equals 0, k equal negative 1, k equal negative 2. So that's where you'd find all your solutions here, right? So if I start here, one hop to the left, that'd be negative 1. And then here, negative 2, starting here at 0. So here, to not bore us, I went ahead and did this. So where I start with the first generator, right? So that's, let me go ahead and, I'm not sure how much of this I can, yeah, I think we can do both. Let's try. So here what we have then, when you start at 1.28700, right? And then I just put in values just so you could see what you would get. You're trying to get values from, oops, that should be a negative, I'm sure. Sorry about that. That would be a negative here. So I'm trying to pull out values that are between, or we have to get from negative 3 pi to 3 pi. So when I put in, pi into each of these, I get, that's about negative 9.42 radians to positive 9.42 radians. So if you start putting in values of k, right, when you put in -2, you're going to have 1.28700 plus 4 pi, right? Oh, that would be, I'm sorry, that would be positive. Never mind. Or no, that would be negative if I put in -2. Sorry, that would be negative, yeah. And so on and so forth. I put in -1 and so on and so forth. What I find is to fit between -9.42 and positive 9.42, -11 is too far beyond, it's more negative than negative 9.42, so I don't want that one. So that one's not going to work. So that's not going to work. But -4.99, that's a good one. So I want that one. That's here. And that's the k equal -1. It's -1 from the 0. When k equals 0, I'm on my starting one that I found that the calculator gave me, 1.28700. And then when I go one forward, I get the 7.57019, this one. And then if I go further, well, then I've surpassed 3 pi, and you can see it, k equal 2, up, I'm more than 9.42. So this is too much. So my solutions are right here, -4.99619, positive 128,700, and positive 7.57019. That's for that generator. Now for this generator here on the bottom, here I'm starting at 4.99, which is right here. So again, you're looking for solutions between -9.42 and positive 9.42 radians. Well, when I start putting in values of k, right, I start at -2, and I'm already within the correct interval for both k equal -2 and -1, and then 0. But as soon as I go k equal 1, I've surpassed 9.42. So what's happening is I'm starting, let's see here, 4.99 somewhere here. And watch what I'm doing. I'm basically saying I'm k equals 0, and then k equal -1, and then k equal -2. So that's what's working out here. So this one's good. So this is good. Remember for the last time. This is good. This is good. This is good. And these are too much, right? So now the point I wanted to make here. So these are fine. These are your answers. This is what you'd write down. These 3 and then these 3. But what I wanted to make a point is sometimes people wonder, well, okay, the books give me this as my solution for the other solution, right? That's this one here where I had to ask, where else is x a length of positive 0.28? And we said, well, it's -1.28700, but I changed it into a coterminal angle between, I just basically between 0 and 2 pi. So why don't books let me do this? It's fine. I don't know, it's usually they just want it to be pretty, but there's really nothing wrong with it. If I had started with this generator, the only difference would be that I'd started here. So then I would have k equals 0 would be here, and then I'd find k equal 1 and k equal -1. And then watch what happens. When k equals -1, there's my 7.578. K equals 0, that's this right here. And finally, k equal 1, there's the 4.99, right? So out of these, this one wouldn't have been good. This is good, this is good. And of course, this is good. This is the one that is the same as that one. And then here you're surpassing it. But notice the numbers are the same, basically, right? It's just where are you starting from? Are you starting from here and then moving back 2? Or are you starting in the middle, moving forward 1 and moving back 1? That's the only difference, okay? All right, thanks so much for listening.